In this video, let me work out an example of Cramer's rule and how we can use it to solve systems of equations. So for example, suppose that we have the following problem. Find the solution for the following system of equations. 2x plus 3y minus z equals 1. X plus y plus z equals 0. Negative x plus 2y minus 4z equals 2. So what we want to do in this case is to find x, y, and z such that this system of equation holds. Now, when using Cramer's rule, we can find the solution in pretty much a single step, because what we need to do is the following thing. We need to look at the column of answers, and we're going to substitute that column with the coefficients of x, y, and z one at a time. So in order to do that, we need to write down the matrix of the coefficients for the system of equations. So we would have 2, 3, negative 1, 1, 1, 1, negative 1, 2, negative 4. So that would be our base matrix for this. Now, whenever we look at, say, for example, the solution for x, what we need to do is we need to replace the constants for the coefficients of x. That means, in this case, that would be the first column, which corresponds to the x coefficients, will be replaced by the constants. And then all the other ones are going to remain the same. So we will have the y coefficients to be the same and the z coefficients to be the same. And then Cramer's rule is telling us that the ratio of these two determinants is going to be the value of x. So similarly, we have that for y, for example, we would have that the y value is going to be just the ratio of the coefficient matrix, the determinant of the coefficient matrix, and the determinant of the same matrix, but whenever we replace the y coefficients with the constant coefficients. So in this case, I will write down 1, 0, 2 for the y's, but the x's will remain the same, which is 2, 1, negative 1, and the z's will remain the same. And we just need to find the determinant for that. That's why I'm using the straight lines in here as opposed to regular parentheses. And then lastly, the z value, the value for z would be the ratio of the determinant of the coefficient matrix, which is the one that we have here as a denominator for all of them. And then my top matrix is going to be that same matrix, but the last column is going to be replaced by the coefficients, the constants that we have right here. So that will become 1, 0, 2 for the z's, 1, 0, 2 for the z's. And then for x and y, that will be the same coefficients, which will be 2, 1, negative 1 for x, 2, 1, negative 1 for x, and 3, 1, positive 2 for y. So 3, 1, positive 2 for y. That means that we need to compute these 4 determinants, and then the answer for that will give me the values for x, y, and z. So what I'm going to do is I'm going to compute these determinants and then find those ratios. So we have that the matrix, the coefficient matrix, has a determinant of, and what I can do is I can just apply the cofactor expansion on the first row to make it easier. So this will be 2 times the determinant of this submatrix, which will be negative 4 minus negative 2. That will give me negative 6. Minus, then I get the next term. So that will be 3 times the determinant of the submatrix with these 4 elements, which will give me negative 4 minus negative 1. So that will give me negative 3. And then lastly, I would get the last term of that row, times the determinant of this submatrix. So that should be -1 times 2 minus -1. So that will give me 3. So what we have in here will be that this determinant is going to be -12 plus 9 minus 3. Yeah, we have 2 times -6 minus 3 times -3 plus -1 times 3. So that will give me -12 plus 9 minus 3. And this will be -15 plus 9, which is, I believe it's 6, -6. Okay, so we have that the coefficients will give me a determinant of -6. And now we just have to find the determinants of the ones for which we replace the variable coefficients. Okay, so we can do something similar for those. We can do the cofactor expansion for each of these 3 determinants that are remaining, or we can just plug them into a calculator. Either way would work for us. So let's work it out. It will be pretty much the same idea. So I'm going to work out, say, for example, the one for z. And this will give me, again, I'm going to do the expansion on the first row. So that will be 2 times 2 minus 0. So that will be 2 minus 3. And then I will get 2 minus 0. And then I get 1 times 2 minus -1. So this gives me a determinant of 4 minus 6 plus 3. And I believe that is going to be 1, 7 minus 6. For the first one, we would get the determinant to be 1 times -4 minus 2, that's -6, minus 3 times -2 plus -1 times -2. So these gives me -6 plus 6 plus 2. And in the end, this is positive 2. And then finally, the y matrix, that will give me 2 times -2 minus 1 times -4 minus 1, that will give me -3, plus -1 times positive 2. So this is going to be -4 plus 3 minus 2. And this will give me -3. So in the end, that means that we can put all of these together. And we would have that the value of x is going to be the x determinant, which was 2, divided by the coefficient determinant, which was -6. The value for y, on the other hand, is going to be the y determinant, which was -3. So we have -3, divided by the coefficient determinant, which was -6. And finally, the value of z is going to be the z determinant, which is 1, divided by the coefficient determinant, which is -6. So this will give me the value of x to be -1/3. The value of y is going to be +1/2. And the value of z is -1/6.